Section 6.3, Special Products, Special Factorization. So, if you recall, we had a whole bunch of special products that we memorized. So now we're going to be doing, rather than writing them as special products, we'll be doing them as special factorizations. And so let me rewrite all your special products as special factorizations. So first, difference of squares. Which is the product of the sum and difference of two terms. So a squared minus b squared is a minus b times a plus b. The sum of squares. A squared plus b squared is irreducible. Over the reals. So you're unable to factor the sum of squares over the reals. 3. The perfect square trinomials. A squared plus 2ab plus b squared can be factored into a plus b quantity squared, and a squared minus 2ab plus b squared can be factored into a minus b quantity squared. The difference of cubes. A cubed minus b cubed. A minus b times a squared plus ab plus b squared. Next, the sum of cubes. A cubed plus b cubed. A plus b times a squared plus ab plus b squared. And lastly, the perfect cubes. A cubed plus 3a squared b plus 3ab squared plus b cubed can be factored as a plus b cubed. And lastly, a cubed minus 3a squared b plus 3ab squared minus b cubed can be factored as a minus b cubed. And so those are the special product formulas. So now let me do some examples, some problems involving that. So let's say on page 277. Let me do problem number 2. In exercises 1 through 41, in exercises 1 through 42, factor the binomial completely whenever possible. And so I have here y squared minus 16. And so I can factor this using the special factorization, the difference of squares. So this factors into the square root of y squared is y, square root of 16 is 4, times the same quantity, except instead of putting a minus, I'll put a plus. And so this is the product the sum and difference of two terms. Let me do problem number 4. 9y squared minus 36. So first, before you factor, let's check to see if there's any terms in common. So in this case, it turns out that there is a 9 in common. And so the least common factor of all the terms is 9. So what remains after I factor out a 9 is y squared minus 4. I can now write y squared minus 4 as the product of the sum, as the difference of squares. So I can write it as the product of the sum and difference of two terms. The square root of y squared is y. The square root of 4 is 2. And so you just multiply by the sum and difference of two terms. Let me do problem number 10. 4x squared minus 16y squared. Again, the least common factor is 4. What remains is x squared minus 4y squared. And so I can write this as the difference of squares. Square root of x squared is x. Square root of 2y squared is 2y. The square root of 4y squared is 2y. Times, well, the same thing except change the minus to a plus. Let me do problem number 18. A squared b squared minus b squared. Again, I can factor out what's in common. B squared. What remains is a squared minus 1 after I factor out the b squared. And so a squared minus 1 is just the difference of squares. So I can write this as the product of the sum and difference of two terms. The square root of a squared is a. Square root of 1 is 1. Times, well, the same term except change the minus to a plus. Let me do problem number 20. 27 x cubed minus 12 xy squared. And so the least common factor in this case is 3x. What remains after I factor out 3x? Well, 27x cubed divided by 3x is 9x squared. Negative 12x y squared divided by 3x is negative 4y squared. And so now the 9x squared minus 4y squared is the difference of squares. And so I can use the special factorization that the difference of squares is just the product of the sum and difference of two terms. Square root of 9x squared is 3x. Square root of 4y squared is 2y. Times the same term, except I'm going to change the minus to a plus. And so I get 3x plus 2y. And so I have here that I factored this completely. Let me do problem number 24. 125 minus 5y squared. In this case, what's in common? The least common multiple. The greatest common factor is 5. So what remains is 25 minus y squared. 25 minus y squared is difference of squares. Square root of 25 is 5. Square root of y squared is y. Times the same term except change the negative to positive. Let me do problem number 30. No, let me do problem number 28. 16 minus x to the 4 And so let's use the difference of squares formula, because this, well, square root of 16 is 4, square root of x to the fourth is x squared. So I can write this as the product of the sum and difference of two terms. Now, 4 minus x squared, well, that's also difference of squares. Square root of 4 is 2. Square root of x squared is x. Multiplied by the same thing, except change your minus to plus. 4 plus x squared, well, that's the sum of squares, so I cannot factor that over the reals, so I'm done. We only want to factor over the integers in this particular case. Let me do problem number 30. 16x squared minus 9y squared. And so this is the difference of squares. Square root of 16, x squared is 4x. Square root of 9y squared is 3y. Times, well, the same thing, except change minus to a plus. Let me do problem number 32. 81 plus y to the fourth. And so, well, it turns out that in this case, I cannot factor this any further. Over the reals. And so this is irreducible over the reals. Okay. Let me do problem number 38. X to the fourth minus y to the fourth. So this will be x squared minus y squared. Square root of x to the fourth is x squared. Square root of y to the fourth is y squared. Times, well, the same thing, except I'll change the minus to a plus. Well, x squared minus y squared, that's the difference of squares, so I can factor that using the difference of squares formula. Square root of x squared is x, square root of y squared is y, times the same thing, except change minus to plus. X squared plus y squared, that's the sum of squares, and that does not factor any further over the reals. It's irreducible over the reals. And so I'm done. Let me do problem number 40. Y to the 4 minus 16 x to the 4. So this is the difference of squares. So let's write this as the product of the sum and difference of two terms. Square root of x to the fourth is x. Square root of y to the fourth is y squared. Square root of 16 x to the fourth is 4x squared. Times, well, the same thing, except change the minus to a plus. Next, y squared minus 4x squared, difference of squares. And so y minus 2x, the square root of y squared is y, the square root of 4x squared is 2x, times, well, the same term except change minus to a plus, times the last term, which is irreducible over the reals because, again, it's the sum of squares. Let me do problem number 42. 81 minus z to the 4 Again, this is the difference of squares. The square root of 81, 9. The square root of z to the 4, z squared, times, well, the same term, except change the negative to change the minus to a plus. Next, 9 minus x squared is just the difference of squares. Square root of 9 is 3. Square root of z squared is z, times, well, the same thing, except change the minus to a plus. 9 plus z squared, well, that is the sum of squares. And so I've completely factored this over the reals. Let me do problem number 44. In exercises 43 through 78, factor the expression completely. Again, when they say to factor completely, they mean to factor over the reals. Well, actually factor over the integers. Y squared plus 6y plus 9. This is a perfect square trinomial. The square root of y squared is y. I have here a plus, so I'll put down a plus. The square root of 9 is 3. Y times 3 times 2 is 6y. Therefore, it is indeed a perfect square trinomial. And so I'm done factoring it. Let me do problem number 46. Z squared minus 10z plus 25. The square root of z squared is z. I'll drop down the minus. The square root of 25 is 5. Z times negative 5 times 2 is a negative 10z. So I've completely factored this over the rationals, over the integers. Let me do problem number 50. X squared plus 12x plus 36. Again, this is a perfect square trinomial. Square root of x squared, x. Drop down the plus. Square root of 36, 6. X times 6 times 2 is 12x. And so I'm done. It is a perfect square trinomial. Let me do problem number 52. X squared plus 9x plus 81 over 4. Square root, again, this is a perfect square trinomial. Square root of x squared, x. Drop down the plus. Square root of 81, 9. Square root of 4, 2. Now let's check that this really is a perfect square trinomial. X times 9 halves times 2. 2's cancel, so you just get 9x. And so this is indeed a perfect square trinomial. And so it's factored as x plus 9 halves quantities squared. Let me do problem 54. X squared over 25 minus xy over 15 plus y squared over 36. So this is equal to, well, again, this is a perfect square trinomial. Square root of x squared, x. Square root of 25, 5. Drop down the minus sign. Square root of y squared, y. Square root of 36, 6. Squared. So let's check if this is indeed a perfect square trinomial. X times negative y times 2 is a negative 2xy. 5 times 6, 30. 30 divided by 2 is 15. So I get a negative xy over 15. And so, yes, indeed, this is a perfect square trinomial. And so we have factored it. Let me do problem number 58. 4x squared minus 32x plus 64. So first factor, what's in common? 4. So what remains is x squared minus 8x plus 16. What's in parentheses is a perfect square trinomial. Square root of x squared, x. Bring down the minus. Square root of 16, 4. X times negative 4 times 2 is a negative 8x. And so this is a perfect square trinomial. And so I factored it completely. Let me do problem number 60. X squared z plus z y squared plus 2xyz. So this is equal to x squared z plus 2xyz plus zy squared. Just writing it in order, in descending order. Now let's factor out what's in common, z. So what remains is x squared plus 2xy plus y squared. And so this is equal to z times square root of x squared is x, square root of y squared is y. X times y times 2 is 2xyz. And so I have factored this completely because that is indeed a perfect square trinomial. Let me do problem number 66. Four a cube plus 20 a square plus 25 a. And so this is equal to a times 4a square plus 20a plus 25. What's in the parentheses is a perfect square trinomial. Square root of 4a squared is 2a. Drop down the plus. Square root of 25 is 5. And let's check if the if the middle term is indeed equal to, well, 2a times 5 is 10a times 2 is 20a. And so this is a perfect square trinomial, and it factors as follows. Let me do problem number 68. (27) a squared b minus 18ab plus 3b. So the greatest common factor in this case is 3b. What remains is 9a squared minus 6a plus 1. What's in parentheses is a perfect square trinomial. The square root of 9a squared is 3a. The square root, and bring down the minus, the square root of 1 is 1. And now let's check. 3a times negative 1 times 2 is a negative 6a. And so I am done. 70. 128 a cubed b plus 64 a squared b squared plus 8 ab cubed. And so I guess I can factor out and 8ab. So let me do that. So the square 128 a cubed b divided by 8ab is 16 a squared. 64 a squared b squared divided by 8ab is 8ab. 8ab cubed divided by 8ab is b squared. Square root of 16a squared, 4a. The square root of b squared, b. 4a times b times 2 is 8ab. Therefore, this is a perfect square trinomial. And it factors according to the special factorization formula. Let me do problem number 74. 36 x squared plus 60 xy plus 25 y squared. And so this is a perfect square trinomial. The square root of 36 x squared is 6x, dropped on the plus. Square root of 25y squared, 5y. 6x times 5y times 2 is 60xy. And so this is a perfect square trinomial. Let me do problem number 78. A to the 4 b squared plus b to the 4 a squared minus 2a cubed b cubed. And so this is, let's write this in descending order. A to the 4th b squared minus 2a cubed b cubed plus a squared b to the 4th. So let's factor out an a squared b squared. So what remains is a squared minus 2ab plus b squared. And, well, what's in the parentheses is a perfect square trinomial. It's actually the same form that I gave you in the formula. Let me do problem number 80. One plus a cubed. In exercises 79 through 85, factor using formulas for the sum of two cubes. And so, cube root of 1 is 1. Drop down the plus. Cube root of a cubed, a. 1 squared, 1. Change the sign from plus to minus. 1 times a. A squared is, well, a squared. And you are done. It turns out that 1 minus a plus a squared is irreducible over the reals. Let's say that. That this is irreducible over the integers. And so I'm done factoring that particular one. Let me do problem number 82. 128 x cubed plus 54 y cubed. I can factor a 2. What remains is 64 x cubed plus 27 y cubed. Cube root of 64 x cubed, 4x. Bring down the plus. Cube root of 27 y cubed, 3y, times 4x quantity squared, 16x squared. Change the plus to a minus. 4x times 3y is 12xy plus 3y quantity squared is 9y squared. And that is your answer. Again, the 16x squared minus 12xy plus 9y squared is irreducible over the integers. Let me do problem number 84. X plus y cube plus x minus y cube. And so, 84. So this again is the sum of cubes. Cube root of x plus y cubed is x plus y. Cube root of x minus y is x minus y. Times, well, the first term, x plus y squared, minus the product of these two terms, times, well, here, let me move this over. Let's move this. Plus x minus y squared. And so this is equal to, well, let's simplify this. This is just x plus y plus x minus y times, let's multiply this out. So x plus y quantity squared is just x squared plus 2xy plus y squared minus, this is the product of the sum and difference of two terms, is the difference of their squares, x squared minus y squared, plus, again, by special product formula, this is a perfect square trinomial, x squared minus 2xy plus y squared. So this is equal to, well, the y's cancel, so I get 2x. The two xy's cancel, and so I get x squared plus y squared minus, I'll change all the signs. Since there's a minus outside the parentheses, I'll change all the signs inside the parentheses. So this becomes minus x squared plus y squared plus x squared plus y squared. One of the x squareds cancel, and so you get 2x times, I have 1x squared, I have 1, 2, 3 y squares, and I am done factoring. Let me do problem number 85. Eight x to the 6 plus 64 y to the 6. So what's in common is an 8. What remains is x to the 6 plus 8 y to the 6. So this is a sum of cubes. Cube root of x to the 6 is x squared. Bring down the plus. Cube root of 8 y to the 6 is 2y squared. Square the first term, x to the 4th. Multiply the two terms, x squared times 2y squared, 2x squared y squared, plus 2y squared quantity squared is a 4y to the 4th. This is sum of squares, so I'm done factoring. And it turns out that this is also irreducible over the integers, so I'm done factoring. Let me do problem number 86. In exercises 86 through 94, factor using formulas for the difference of two cubes. Z cubed minus 64 is, well, Cube root of z cubed is z. Cube root of 64 is 4. First term, square it, z squared. Change the negative to positive. Multiply the two terms. Z times 4, 4 is z. Plus square the last term, 4 squared 16. And the z squared plus 4z plus 16 is irreducible over the actually over the integers, over the rationals. Let me do problem number 88. Y cube minus 125 z cube. Again, difference of cubes. Cube root of y cubed, y. Cube root of 125 z cube is 5z. Square the first term, y squared. Change sign, plus. Multiply the two terms, y times 5z, 5yz. Square the last term, 25z squared. And I am done. Everything remaining cannot be factored over the integers. Let me do problem number 90. 8 x cubed minus 125 y cubed. Again, it's the difference of cubes. Cube root of 8 x cubed, 2x. Cube root of 125 y cubed, 5y. Square first term, 4x squared. Change sign, multiply the two terms, 10xy. Square the last term, 25y squared. And all the remaining terms cannot be factored over the integers, so I'm done. Let me do problem number 92. X minus 8xy cubed. Factor the x. What remains is 1 minus 8y cubed. What's in the parentheses is the difference of cubes. Cube root of 1, 1. Cube root of 8y cubed, 2y. And you bring down the minus. 1 squared is 1. Change the sign. Plus. Multiply. 1 times 2y is 2y. Square the last term. 2y quantity squared is 4y squared. And so I factored these completely over the integers. Let me do problem number 93. X cubed, x to the 6 minus y to the 6. So I can factor this doing, well, two different ways. So my first try, let me note that this is the difference of cubes. And so the cube root would be x squared. Cube root of y to the 6 is y squared. Square the first term. Change sign. Multiply the two terms together. Oh, I'm sorry. The first term squared is x to the 4th. Take the last term and square it, y to the 4th. And so this is the difference of squares, x minus y times x plus y. Next, I have here x to the 4th plus x squared y squared. Let me write this as 2x squared y squared plus y to the 4th minus my x squared y squared. So I can just add and subtract x squared y squared. And so what I'm going to do here is try to factor this by grouping. So I'm going to group the first three terms in the last term. So this is equal to x minus y, x plus y, times, well, I can write this as x squared plus y squared squared, and this term is xy squared. And so this is the difference of squares. So x minus y, x plus y, times, well, let's do the difference of squares. So it's the first term, the square root of the first term, minus the square root of the second term, times, well, the same thing, except I'll change the minus to a plus. Now let me get rid of the parentheses. So I get x minus y, x plus y, times, well, and let's write this in descending order, x squared minus xy plus y squared times x squared plus xy plus y squared. And so we have factored this completely. So it turns out that whatever is in parentheses in this case cannot be factored any further over the integers, over the rationals. Let me do this again. So let me do my second try to factor this. And it turns out that if I'd done it differently, it'd be much easier to actually factor this. So my second try, x to the 6 minus y to the 6. Rather than doing this first as a difference of cubes, let's do it as a difference of squares. So x cubed minus y cubed times x cubed plus y cubed. And now let's use the difference of cubes formula. X minus y, x squared plus xy plus y squared. And, well, maybe I can move this over and I'll get everything in one line, hopefully. And now x cubed plus y cubed, well, it's the sum of cubes. So x plus y times x squared minus xy plus y squared. And you're done. And so, note, use difference of squares first. Of squares before you use difference of cubes. So if you do that, it turns out that it's just much easier to factor. Okay, so if you do the even powers first, it'll be much easier than using the odd powers. Okay, so use formulas with the evens first if you've got a choice. So if you have a choice, the choice is to do the even powers first, and they'll usually make your life much easier. So that was what, 93? Let me do problem number 94. One over 216 minus 729 y cubed. Okay? And so okay, so this is equal to, so let's do the cube root of 216. Well, wait. And so that's going to be 6. Minus. So the cube root of 216 is 6. And so the cube root of 1 over 216 is 1 over 6. The cube root of 729 is 9. Cube root of y cubed is y. Times, well, 1 6 quantity squared is 1 over 36. Change minus to a plus. 9y times 1 6, well, 9 divided by 6 is 9 over 6 can be reduced to 3 over 2. Plus 9y quantity squared is 81y squared. And you are done. Okay. And let's see, I think that might be it for that section. And so I guess we are done.